Hello and welcome to Making Awesome. Today we are going to be talking about ABS versus PLA versus PETG. I'm Tad, this is Grant, and
Let's get
let's,
to it.
yeah.
So, commonly, there are three main materials in the 3D printing industry
Mhm.
where desktop grade 3D printers can generally play in. You have PLA, ABS, PETG. They are all good for certain things, terrible for other things, and they all have their reasons. So, uh, Tad, let's have you start off with ABS. ABS is one of the oldest materials for 3D printing. It was actually the first one that consumer printers had because it's cheap, it's ubiquitous, and it is very, very easy to extrude and obtain. So let's
Right,
talk about ABS and its uses, not just in 3D printing, but overall.
right. ABS is acrylonitrile butadiene styrene. It's a mixture of different monomers that form that polymer. Um, and prior to 3D printing coming onto the scene, ABS has been for a long time and still is used for pretty much any kind of tough plastic part that you are used to coming into contact with. Anything that needs like impact resistance, or a lot of times anything outdoors is made out of ABS. And Legos, of course, famously are made out of ABS.
That is
Um,
Lego, sir. The
oh, it's
the
already
plural
plural.
of
Oh, for
Lego
God's
is
sake!
Lego. It's like share. Get it right.
Uh, shit. Um, but yeah, it's extremely common. It's easy to come by. Um,
It's dirt cheap.
it's very yeah because of its availability.
And it's oil based,
Hmm.
which is it makes it both wonderful and absolutely terrible at the same time.
And it smells awful.
Yes, if any of you have ever had a plastic object burn, maybe you've left your air fryer on your stove, not going to call anybody out, but that's definitely not happened in my house. Maybe you've had a curling iron that got too hot, or a cheap toaster decided to let out the smoke. You've likely smelled ABS. If you've had if you've burned plastic for whatever reason it might be, we're not asking you to tell us. Okay, we don't need to know about what you do behind closed doors.
Well, and
But
sometimes you don't even have to burn it. You could just like break it in half, and you'll
that's true.
smell that.
And it's that styrene that
Yeah,
makes it smell, and the butadiene, right? Because
yeah,
it doesn't make butyric acid. Butyric acid, if any of you have had anything that's rubbery and it gets sticky, that's butyric acid. That's what it does to
yeah.
stuff. And the butylene is what makes it, or
Butadiene,
butadiene,
butadiene. Yeah,
butadiene. See, I'm not a chemist. I have
don't
two
worry
business
about it.
degrees. That's what makes it a little bit flexible. The styrene is what gives it one of the properties that I personally hate.
Yeah.
It shrinks a
Hmm.
lot. This, if you are watching on YouTube or on your favorite watching platform, you can see I'm holding up a piece of ABS filament. This is, we have one printer in the shop that we run ABS on. It is our Fusion 3 F410, available through 3D Musketeers. You can reach out to us and we're happy to get you handled. But the only reason we run it in that machine is because it is not only enclosed, it is also filtered. It has a exhaust fan that is HEPA and carbon filtered. That makes it bearable. You can
Because
still
it's
smell it.
uh,
I
it'll fill a room.
It does, and it gives me a freaking headache. I
And
cannot
I mean,
stand the smell.
there's some evidence that it may not be good over the long term because it can
No, it's
kind of.
definitely, if things don't smell good, they're not good over the long term,
Hmm.
okay? And that goes for all facets of life, kids, all right? Think about it, okay?
Yeah.
Look, we all know durian doesn't taste bad, but it stinks. Don't eat it. Um, so ABS started because these machines that people were using to do the extrusion were old weed whacker line machines. Those ran nylon.
Hmm.
Nylon sucks. Nylon's very tough to deal with. We're not going to get into it in this particular lesson, podcast, whatever.
Mhm.
But we will talk about it when we have our exotics. It's a shame we couldn't get Carol Baskin or Joe Exotic to join us, but no, it's not a shame. I'm glad they can't join
I was
us, and
gonna
we're
say.
not going to ask. I mean, geez, I'm like 30 minutes from Big Cat Rescue, but let's not get into that. ABS is easy to work with because it extrudes very easily. Out of all the three materials we talked about, ABS, PLA, and PETG, it is the most temperature resistant at 105 degrees centigrade. That's what, 221 degrees Fahrenheit?
Something like that.
Yeah, that's Wikipedia says 221. Okay, I was trying to sound cool, but I'm really just reading the TG from Wikipedia. Because, yes, Wikipedia is a valid source for your information.
It really is.
It really is. And 105C means it can handle boiling water. Barely, but it can handle boiling water. That's what makes it great for use outdoors. Now, the one downside to ABS outdoors, UV.
It will get brittle.
ABS, not a huge fan of UV. There is a material that has solved that. We're not getting into it. It's called ASA. We're not going to get into it. ASA is damn near identical in terms of its qualities for printing, but it's good for outdoor. ABS, though, shrinks when it cools. And that's great for injection molding because they pop out of the damn molds on their own, basically. You need half the ejector pins that you would need versus a material like a PLA or a PET simply because it shrinks and it pops right out. But it's also going to stink. I cannot imagine what an old school shop that's running pure ABS smells like.
I know exactly what it smells like.
God, that must be terrible.
It's not fun.
Our local manufacturing facility that we go to for injection molding, Spectrum Custom Molds and Manufacturing, they use Triton, which is a modified version of ABS. It's clear, which is cool, but it doesn't stink as much. I mean, it still has a smell, but it's not this arid, humid, gross. I hate it.
It's like a sour smell almost.
Acrid is the right one, but I'm always afraid when I say acrid, I'm going to say Akron. And like maybe the two people that are listening from Ohio are going to get mad at us. They're going to get even more mad when I say go green. But that's fine.
No, like my shop professor had a injection molding business that he ran out of like a little commercial kind of garage thing. And he had two injection molders in there. And I remember I worked with him to clean up parts for, what the hell is it called? I believe it's called the Arsenal. It's a little camera accessory. So this was the two halves of the case for it. And I made a good amount of money clipping those things off of the sprue. And that place, a hot afternoon in there stinks from all that ABS.
I feel like the air gets heavy.
Yeah, a little bit.
Stank.
Ugh.
But ABS is great because it's easily extruded. So back in the day, 3D Musketeers, we used to make our own filament because filament was egregiously expensive. For a kilo of PLA, we used a Filastruder. Hey, Tim, how you doing? We could get a kilo of PLA a day, reasonably. And let's not talk about diameter accuracy or anything. We did not have our machine set up well, but it worked for what we needed. ABS, we could get a kilo every 2 hours because it would just run. It'd be like water coming out of this machine. If you got the temperature right, it would work great. Unfortunately, getting the temperature right is not always the easiest thing.
Did you cook a couple batches?
Yeah. And ABS is a lot more forgiving in temperature than the others. Right? You can overheat it. It's not going to care too much. It'll burn, especially if you're using natural ABS. It'll burn and it'll turn brown. That's always a good way to check it. ABS, though, tends to be one of the cheaper materials out there because it's not popular anymore. What is becoming more and more popular, it's actually the most popular material right now, PLA, otherwise known as polylactic acid. Is that right? I think it's polylactic acid.
Yes, it is.
That's the wrong one. Polylactic acid. Yes, polylactic acid. a lot of you might have experience with it, even if you don't do anything with 3D printing. Oh, my director of marketing is on my keyboard. Thank you. Thank you. Ma'am, ma'am. Oh, well, she bit me. You know, directors of marketing and all.
Yes.
It's the cat. Our director of marketing is Cat. Maybe if she behaves, we'll bring her on. So if you're watching on YouTube, you'll get a cat tax. But no, PLA, you might have some experience with it. If you ever went to Starbucks and used a cup that says, do not put hot water in it, it's PLA.
Yeah. All kinds of compostable food packaging now.
Yep. It's all PLA. That's actually where PLA is gaining the most room and growth is in the food packaging industry because it is biodegradable. Now,
in certain conditions.
Yes, technically it is considered biodegradable, but it must be damn near
hot and moist,
perfect conditions for
and
it to biodegrade. I'm going to hold up some PLA here. You know what? Actually, let's go back to the ABS real quick, guys. If you're watching, I'm going to bend the ABS in half. It broke. It shouldn't have broken.
How old was that strand?
It might be old. It might have uptaken.
That might be why.
Let's see if I can do it again here.
It's not supposed to do that.
No, ABS is supposed to bend. But, you know, it's not snapping. It's just kind of like shearing. Now, this has been through an extruder, so it's got lines on it. So I wonder if that...
Oh, it's like just shearing along those striations?
It is. It's shearing along those striations.
Yeah. So if you got like a clean piece that hadn't been through anything, you'd be fine.
You know what? If I bend it the other way, right, away from it.
Yeah, there you go. There you go.
Yeah,
That's
there's
what
the bend.
you're looking for.
And it'll bend all the way in half. And I don't know if you can see it.
It gets a little white.
It discolors. It turns white. Now
it's from those polymer chains kind of going like this.
Yeah, they're like
flipping past each other
as they're very slowly being stretched to their limit. PLA is considerably more brittle. Watch. The thing with PLA though, when it uptakes water, it gets flexible. So we'll do the same thing. Yeah, when it uptakes water, it gets flexible.
Yeah, but I know what you mean. I have a piece here that I.
And if you look, when you bend PLA, it tends to just it turns to non-elastic deformation.
Snaps right off.
This one didn't completely break, but I bent it one more time and it broke in half. So PLA is
it's
more
considerably less rubbery.
Yeah, it's like spaghetti.
Yeah, like dry spaghetti.
And when it's like fresh right out of the package, it will crack into pieces if you try to bend it like that. Similar to how you can never break spaghetti into two pieces.
It just goes,
you can't. Yeah, same thing with PLA.
And you know why that is actually?
No.
There's a shockwave that travels through it that causes further fractures.
Cool.
That's why spaghetti does that.
Science.
Yeah, it oscillates.
I love science. And if you don't love science, you're probably listening to the wrong podcast. Because we're going to make really crappy science jokes. No, that's not in the script. We're actually going pretty much off the cuff on this one. We've got our Wikipedia links for everything, but otherwise we're going off the cuff because this is a pretty simple topic. But it can get a little nitty gritty, right? PLA is great for 3D printing because it barely shrinks. You don't need a heated bed, which for ABS, you need to be at 110 plus degrees centigrade, otherwise known as expletive deleted hot.
Yeah.
PLA.
Because it'll warp otherwise.
Oh, yeah. And if you're using a Cartesian printer, which the bed moves forward and backwards or left to right, whatever way it moves, that's bad. You have to put like a cardboard box over your printer, which you should never do because that's also flammable. You're basically feeding your printer highly flammable stuff.
Yeah.
Don't print unattended. I don't care.
Slinging is like somebody blowing on it constantly.
Yeah, it's convection cooling.
Yeah.
PLA says, you don't have a heated bed? Great, we don't care.
Yeah.
Blue tape was used for years. The first 3D printers that we all built did not have heated beds. It didn't exist. We didn't have a good way of keeping that temperature variant accurate. So you were forced to print PLA, or you are forced to make a raft, which is, we'll get into that with
Oh, I remember those days.
Yep, the old school styles of 3D printing where you built a sacrificial component underneath your real part that would warp. You expected it to warp. You designed it to warp, so that when you were printing, the ABS that was warping had nothing to do with your own part. You made sacrificial material. But heated beds really remove the need for that. PLA, though, can print on basically any 3D printer. It is incredibly simple to print. It needs very low temperatures. Like your printing temperature for ABS is 240, 235, up to 250, basically. For PLA, I've seen people print as low as 185. We print a little bit above 200 just because we like to run ours a little bit faster, but it's not needed, right? PLA's happy at basically any temperature. We've got, for our TAS 6 right behind me, we have the Musketeers, which has a 1.2 millimeter diameter nozzle, and it's 3 millimeter filament, so you can run those kind of nozzles. But you're able to get any amount of speed, which is like 40 millimeters a second, by the way, out of that machine, with the Musketeers, and 1 millimeter thick layers, which is comical to watch 5 layers go down at once. You need to run PLA at about 260 degrees centigrade. And as long as you keep it moving, it doesn't care, right? If you stop and you leave it at 260, it's going to melt very quickly away from the heat. So it'll melt through your hot end, drip onto your printer, and that's it. It wants to be away from heat. And that's a great thing about it. The problem with PLA is it is very, very viscous. Same with PETG.
It has an extremely low glass transition temperature too. It's only like 60
Yes.
degrees C.
I believe it is 60 C. Do we have a number? It's 60 or 65. It's not very high. We tell people 140 degrees Fahrenheit. And here in Florida, I don't care what color your car is. I don't care what color your interior is. If you don't put a sunshade up and you leave your car outside, your car will reach above the glass transition temperature of PLA.
So don't leave it in the trunk.
Right. I have a silver car with black interior, and I accidentally left one of our large demonstration parts in there for 2 minutes with the door closed while I was getting parts out of the trunk. And I went to get this thing out of the front seat because it's too big to fit in the trunk. It had started to warp. So the material, it was also black, so the material absorbed a ton of heat. Is what it is, right? I mean, that's just the way it goes. We made a new part, and the failed one sits in my living room as a joke. Failure is always an option. But the nice thing with failure in 3D printing is you're out a lot of time. You're generally not out a ton of money. PLA is also great because the smell. I love the smell of PLA. Some people love it. Some people hate it. I happen to love it. It smells like breakfast. Smells like waffle. Smells like sugar because it's made of corn. So it's corn syrup.
Plant derived. Yeah.
Right. And so it's lactic acid, polylactic acid. Lactic acid, if maybe you remember two school chemistry, that's what gives you cramps.
Yeah, muscle cramps.
Buildup of lactic acid. So this is lots of, it's 2 main chains of lactic acid put together to make plastic. Yeah. It's pretty cool. And when you think about it, what that means for your muscles, the mind boggles.
Yeah, it's
the mind boggles.
Never would have thought that.
Yeah. Anyways, the material's great to print with, though. Yeah. It's brittle. It's very brittle. So, like hitting a part made of ABS, the hammer will deform it, but will bounce.
It'll leave a dent, but
it'll leave a dent.
You could run a car over it, though.
Oh yeah, you can run a car over it. PLA, if you hit it, it's probably going to break and shatter on you. It's not going to shatter like glass, but it's going to shard, right? Yeah. It's not going to be like tempered glass or just a bajillion pieces. But if you slowly load PLA, it's a phenomenally strong material. You can run it over with a car, no problem. But that's also because of how cars transmit weight through tires. That's a different subject.
It's not a hard object.
Right. If your car had tires made of wood or steel, it'd be different for all these materials because that's just pressure, your point loading.
Yeah.
So PLA has a higher density, I believe. Let me see. The density of ABS is 1.06 to 1.08 grams per cubic centimeter. For reference, water is 1 gram per cubic centimeter. So ABS just barely sinks, which makes it really great for doing things like fishing weight or fishing bobbers, because they don't need a lot of air pocket in them to float.
Mm-hmm.
Looking at PLA, it's 1.21 to 1.43 grams per cubic centimeter, considerably heavier. That's about 20% heavier on the low side. And on the high side, geez, you're over 30% heavier. That's a lot. And that translates to less material. When you buy spools of 3D printed plastic, you buy it by weight. You do not buy it by length. So when you're in your slicer program and you're looking at, how much material it's going to use, make sure you have your density set correctly, because you might run out of filament.
Mm-hmm.
So let's move forward on to PET. PETG is a glycol modified variant of polyethylene terephthalate.
Phthalate, right?
There you go. See,
Yeah.
Sure. And it's glycol modified. So PET is very common in food packaging. PETE is a milk jug, a soda bottle. What's this cup made out of? Well, I can't see because it's mildly translucent and it's full of water and I don't want to tip it over. But PET is very common. It's easily sanitizable, not with 3D printing, of course.
Right. Because of the porous...
the porous nature.
Not perfect surface.
Let's see. I know PET is about 85 C for its TG. Mm-hmm. I'm trying to see if it's specifically listed. We say about 185 to 190 degrees is about as hot as PETG can get. It's generally stable in vehicles, and it's recyclable. It is not easily biodegradable, but it is recyclable. So it's considered standard recyclable plastic.
Yeah, anywhere you can recycle plastic bottles and stuff, you can usually recycle PET.
Yep. PET is also quite viscous. It's, I just had it. It went away from me. 1.38 grams per cubic centimeter. Most PETG runs a little bit lighter. So that's just glycol modified PET. Like PLA, it doesn't shrink all that much, but it shrinks a little bit. It does like to have a heated bed. Normally around 70 to 85 degrees centigrade is perfect for it. It does need to print a little bit hotter, right? So it's a little bit more of a challenging material, and it's right on the edge of what most cheaper 3D printers can handle, because its temperature you print at is right around 235 to 270 degrees centigrade, not Fahrenheit.
But on the flip side, it's quite a bit tougher than, say, PLA.
It is. And it also, its natural state is almost glass clear. It is, let's make sure, because this is also previously extruded. I just cut stuff off the spools that we had. It does not, similar to ABS, it will want to deform and bend before it breaks. This is like the same thing over and over, and we're still not broken. That is really, really nice for PET. The downside to it is it strings so bad. And there are ways to combat it. The normal system is add an extra millimeter. So if you're at 1 millimeter retraction for PLA, you want to go 2 millimeters for PETG, and you want to do it very fast because it will have a tendency to stretch rather than pull away from the nozzle when you're doing your retraction. Yeah. But, for what we do here at 3D Musketeers, we are basically always printing in PET. You guys, if you're watching on video, you've seen this Fusion 3 running basically every single time that we've been recording, and it's always printing in PETG. If it's printing something else, I'll let you know. But we had a really big order of parts that are too big to fit on any other printer in our shop that's functional.
Do you have the failed one?
Yeah, I can show a failed one.
Yeah.
Oh, hey, it literally just finished.
Oh, there's the bed going down.
Yeah, it's going down.
Hey.
Here's a failure to give you guys an idea of how big it is.
Yeah.
It's
And
a
that's
big
one of
part.
how many? 12?
12. Yeah,
Yeesh.
so that's I guess that's number 10. That's number 10.
You're almost there.
Yep. Now it just has to cool down because that printer has a glass bed. PETG does have a problem with certain bed materials. It will weld itself to any PEI, which is polyether imide. That is a exotic plastic that we will talk about in another episode. But the way to fix it is either a little bit of glue stick, which oddly
Is that what the
will,
glue stick is for?
it's more for polycarb, but yes.
Oh, okay, because my Prusa kit, for those who don't know, I just built a Prusa Mark III S, which is behind me here.
Best
And it
darn
came with a
printer
glue
for the
stick,
money.
and I'm like, the hell is this for? Now I
It
know.
is. It's for certain materials that will have a tendency to weld themselves to the PEI sheet.
So it just
Because it
keeps
is
like creates a little barrier.
right. It's a little barrier layer, right? It's
Mhm.
we use Windex. The industry kind of goes over to Windex. If you're printing polycarbonate, which again, another
A
video
little bit
for
exotic. Yeah.
that. You absolutely need that glue stick because it will never come off of that printer without ripping the bed. Like if you print polycarb on a bare PEI bed, cut the PEI off around the part because you will not get it off otherwise. We've had parts weld to glass beds where I'm like, yep, we're going to take this one over to a trash can and we're going to hammer the bed and just break it because the bed is cheaper
You're never
than the
getting
part.
it back.
Yeah, you're never going to get it back. And PEI has become a very standard build surface. There's build tack, which is some sort of plastic polymer that works great as well. Prusa printers use a smooth or powder-coated PEI sheet. And PETG is highly recommended. Actually, all but 2 pieces on a Prusa i3 Mark III's kit are printed in PETG.
What
It's
are the 2
rugged.
parts?
The hot and cooling fan and one of the covers for the hot end are printed in ABS. They might have gone, oh, actually, no. They changed over to ASA recently.
Right.
It's minor ABS because our printers here are older, but the newer ones, your printer probably came with a bottle of Prusa graphite lubricant, right?
Right, yeah, the little one. Yeah.
They never came with that for the original ones. So the newer ones, as Prusa finds things that are needed, that's what they do. They add more stuff in there for you so that it comes with everything you need, including gummy bears, because that's really what you bought. Just came with a free 3D printer. But PET is a great material in printing. It's practical, it's engineering grade, and it's very similar to ABS in temperature, in its flexibility and everything like that. So we love PETG here. I'm starting to open up more to ABS now that we have the Fusion 3 fully enclosed.
You don't have to worry about the warping as much.
It's not even, you know what? I can deal with the warping, right? It's like, okay, until you really figure it out, you're going to lose a bunch of prints. Fine.
Yeah.
I cannot under any circumstances deal with the smell. It's terrible. It goes through the whole shop. And it smells like someone burned plastic, and I hate that smell. But thankfully, Fusion 3 has carbon filters that take out most of that smell. And really, the only reason the room will still smell is because there's little air leaks.
Yeah.
Because we have a custom part to move the filter so that it doesn't touch the wall. And it's printed in PLA, so I assume there might be some areas where some air can get through. So I probably need to coat it in some 2-part epoxy.
Something like that.
Yep. But that's okay. That's the way she goes. And, part of the whole system. I mean, this is a short one. There's really not too much that we have to talk about there. PET, ABS, PLA, they're all good materials. They all serve specific purposes. Let us know what you think. I mean, God, this is like maybe a 25-minute video at best.
Unfortunately. I mean, the only thing I think I could add is, as you were saying, PETG, and ABS are considered engineering plastics, in which they're a commodity plastic. You can get them everywhere. They're used in injection molding extensively, which helps their availability for 3D printing. But PLA is not a commodity plastic.
Not yet.
No, it's getting there though. I mean, the amount of use it sees in the food packaging industry, I'm sure is getting it there quickly.
Yep. Like to give everybody an idea, plastic straws. big deal if you're ever on the West Coast. Florida is starting to adopt this. Hey, you know, we probably shouldn't use non-biodegradable plastics anymore. And the city of Gainesville actually banned all non-biodegradable or non-recyclable plastics. And they classified ABS as a non-recyclable plastic. This is
I
for
don't know.
food. It's for food packaging.
Yeah.
And there's not a lot of food packaging that was made out of ABS anymore. The lot of it was going over to polystyrene because it is really cheap. Polystyrene does not biodegrade. There are like certain organisms.
Styrofoam. There's polystyrene.
Yeah, it's styrofoam. Everyone knows styrofoam, and everyone knows like the really tough styrofoam that doesn't break, and then the stuff that comes with the cheap stuff that you buy, and the little peanuts go everywhere, and it sucks.
Yeah.
I mean,
the sad thing is, oh, go ahead. Sorry.
We've even seen packing peanuts move away from polystyrene and going over to PLA. They're cornstarch.
Yeah.
If you want to mess
Well,
with
a lot of them are already like that cornstarch stuff. So
the city of Gainesville require this, and we do a lot of work in the food packaging industry. So our food packaging clients said, hey, you know, these are the materials we're moving over to. We're moving over to bagasse, which is, if you've been to Chipotle, the bowl, that's bagasse. It's corn.
And a papery.
Yeah. It's like corn husk, basically. It's a byproduct of making corn syrup. And they're going over to CPLA, straws, lids. CPLA is just crystallized PLA.
Yeah.
Biodegradable.
They're kind of like opaque, whitish plastic.
Yeah, and it's generally seen as like a ocean blue, teal kind of color. Because its main color, it's like an opaque white. Or semi-translucent, I guess.
Yeah, kind of frosted.
It's not pretty, and they'll add a little bit of food coloring-based dye to clean it up. A problem, of course, is they're much heavier than ABS, so the shipping cost was something that everybody had to figure out. But, you know, we're seeing a lot of changes in the industry. PETG is becoming more commonly used. ABS is really going out of the industry unless you have high-end 3D printers like the Fusion 3F.
And you need the temperature resistance or something.
Right. And, you know, there are materials like, there are blends, right? There's ABS Plus, which there's a lot there to really process. And maybe we'll go into some of those plus materials, those PLA Plus, ABS Plus. That are slightly modified, right? ABS Plus is supposedly doesn't smell and is much easier to print. Never tried it because by the time ABS Plus came around, we had basically switched over to PETG. And the bulk of people that think they need a exotic plastic like a nylon really are fine with PETG, especially when they find out the cost differentials when it comes to manufacturing. But I think that's really it. I mean, this was a short one. We knew it was going to be short. Maybe we'll make this like a clip or a bonus episode. Who knows? But, you know, look, guys and girls, ladies and gentlemen, we never want you to stop making. And the goal of this podcast is to help inspire you, help teach you, help guide you in your processes, trials, tribulations of making awesome. We want to hear from you. We know there's not a lot of you right now, but who knows, maybe there could be in 2 days, 2 months, 2 years, 2 millennia. Our voices, our faces are out there forever for better or worse reasons. And we want to help you. Our goal is to help you. And if you are stuck, if you don't know what plastic to use or what step you need to take next, reach out to us. We're going to have a website link in the description where you can go to 3D Musketeers, which is they're the sponsor of this podcast. I'm the owner and Tad's a lead engineer, I should say, of 3D Musketeers. You know, we want to help you, and we want to offer anybody a free consultation to talk about your product, what you can do with it, and how we can help you make awesome. And if you know what you're doing, great. We want you to reach out to us too, because we would love to have guests. We're looking for another host. We'd love to have more people come on, hang out with us and talk, because, you know, we find that especially when you get more minds that are all moving in the same direction, all firing on as many cylinders as we can muster that day, you get a lot of interesting conversation. Some of these will be longer than others, and that's okay. But, you know, we always want to remind you to stay safe out there. don't, if you're over on the West Coast, good Lord, get the hell out.
Get
Stay
a
away from the
respirator.
fires. Get a respirator. Uline sells them. I don't like Uline, but they sell them. Sorry. Do what you got to do, guys. Stay socially distanced. Be safe. My name's Grant. That's Tad. This has been ABS, PLA, and PETG. Benefits, negatives, and why. This is Making Awesome. Sponsored by 3D Musketeers. Not really sponsored, but
run by.
Run by.
Yeah.
Supported by 3D Musketeers. We hope you guys out there are staying healthy and continue to make awesome. Have a good one.
Thanks for joining us.